Okay, I'm going to walk you through level 2. And question 1 is this area of this curve, x-axis, and the line x equals 4. So I want to see what that looks like. Well, when x is 0, y is 1. When x is 0, y is 1. When x is minus a half, y would be 0. And it wants me to go up to 4. So when x is 4, y is going to be square root of 9, which is 3. So that's enough points there for me to get a picture of what's going on. And I want between the x-axis and that line, x equals 4. Basically, you're integrating between minus a half and 4. Write that in bracket form. To integrate a bracket, make sure you've got the derivative in front. The derivative is a 2. Balance it outside. Once you get that done, add 1 to the power. So it's, should have the square brackets in yet. Sorry, so we'll add 1 to the power. Divide by the new number. And now put your wee square brackets and limits in. So that all tidies up to 1 over 3. And then that is the square root of 1 plus 2x cubed. And then all you have to do is sub in your 4 and sub in your minus a half. Number 2, it says integrate this expression here. So as I'm writing this out, I'm seeing a bracket on the bottom because it's to the power of a half. So I would write that as 1 add x squared to the minus a half, just bringing it up. To integrate a bracket, you must have the derivative in front. The derivative, that's a 2x. I've got an x, so pop a 2 in and balance outside. I've now got the derivative of the bracket, so I can integrate. Add 1 to the power, divide by it, and don't forget your c. Half divided by half cancels off. 1 plus x squared, square rooted, plus c. In my notes, I've also shown you how to do it by substitution. But say in real life, an exam question, I wouldn't do that. I would just go straight for the method I've just shown you there. Right, question 3. I'll just write both of these out. And then I can get rid of the phone. And part 2 is 3x, 1 add x squared dx. Okay, I don't have a bracket in the bottom, so I'm going to treat it as an x function. So that's going to be a log. I must have the derivative on top. Derivative of that's a 2. I don't have a 2, but you can make a 2 up there and balance outside by a half. I've now got the derivative on top, so you just log the bottom line and put in your wee plus c there. This one here, again, it's just an x function. I must have the derivative of 2x on top. This 3 is a pain. Just move that 3 outside, out of the road. Now remember that has to be a 2x. Pop your 2 in and balance outside. Now you're good to go. Log the bottom line and plus c. Number 4. I have got x squared over x cubed add 2. Oh, sorry, going off the camera there. So x squared over x cubed add 3. So it's the x function at the bottom. So it's going to be a log. Do I have the derivative on top? The derivative of that is 3x squared. So I need to pop a 3 in there and balance outside. Now I'm good to go. So it's a third, log the bottom line, and that's got limits. So just put in your limit of 1, your limit of 0, and subtract the 2. Number 5, part 1. 1 minus 2x over 1 add x minus x squared. It's an x function in the bottom, so it's a log. Do I have the derivative from the top? So what is the derivative of this? If you differentiate 1, it disappears. That goes to a 1, that goes to minus 2x. Yes, I do indeed have it. No balancing necessary. So you just log the bottom line and don't forget to do your add c. Part 2. Find the derivative of it, or integrate this. Now, it's integrating a bracket here. What's the derivative of the bracket? Again, if you're not familiar, just go over to the side and differentiate it to find your derivative. So 1 disappears, ax goes to ax with the 1 in front. My derivative is here, so I can integrate the bracket, that's the power of 1. To integrate the bracket, add 1 to the power, divide by it. And don't forget your c. Question 6. Okay, differentiation is not overly pleasant, so it's wanting us to differentiate this. Okay, it's a product rule. Now if you remember the product rule, u is the first, v is the second, you do du by dx, dv by dx. You need to learn these techniques off so well, otherwise you'll always get stuck with this. If you know your rules, it's not too bad. So x dv by dx plus v du by dx. So that cancels to 1 plus log x. And use the result to find the integral of log x. Okay, so let's see what we're talking about here. Consider, it says use this result, so let's see. I've just differentiated that from. Okay, so let's just split this up into the integral of 1 dx plus the integral of log x dx. The integral of, differentiating that is, so integrating that is x. Now, integrating this log dx, I'm just going to write it like this. Do you see this one here? You differentiated that up above. So if I was going backwards, that is going to go back to x log x. Okay, I'm integrating it, so put a plus c. I want to find this one on its own. So if I just move this over, it's a very strange question. Don't particularly like this one because it's making you go in all sorts of directions. That's what they're looking for. I have now shown you how to integrate log log x dx. Not the greatest question, to be fair, so wouldn't just stress too much over that one. Okay, we've forgotten question 7. This is more like it. Right. Do you have the derivative on top? Okay, what is the derivative of this? If you differentiate sine, it goes to an ordinary cos. I've got that. Again, if you're not familiar doing it in your head, just go over to the side, differentiate this. I've nearly got it on top. I need to put 2 in, so you balance outside with a half. So then you log the bottom line, and don't forget your c. Point 2. 1 add ex over x add ex. Do I have the derivative on top? Okay, if you can't differentiate that in your head to get the derivative, just go over to the side. Differentiating that, I do indeed have it on top, so I just log the bottom line. Oh, it's not a plus c because I've got limits. So put in your limit of 1 and put in your limit of 0 and tick them away. Okay, question 8. Here's a typical question. Make sure you learn this one off. I show you this wee technique. Treat that, I'm going to put the sin x first, and I'm going to treat the cos as a bracket. Now, do you remember how you integrate a bracket? You must have the derivative in front. So, let's work out the derivative of cos. So if you differentiate that, it goes to minus sin x. I nearly have the derivative here. Put a minus sign in and balance outside. I've now got the derivative of the bracket in front. So you add 1 to the bracket, divide by it, and don't forget your c. And number 9, find the area bounded by the curve y equals 2x. Let me draw that first. So it's just an exponential graph. When x is 0, y is to the power 0, which is 1. The x-axis, the y-axis, and the line x equals 1. So where's my line? X equals 1. So I want this area. So I am going to, the area is when you integrate between 0 and 1 of 2x dx. Now, to give you any hints for this, give your answer in terms of that. No, I was checking there because quite often in this question it would give you a wee hint. Okay. In an exam, I'd expect part A to be leading you down the direction you have to go down. I'm going to write 2x as e log 2x, because remember the e and the logs cancel each other out, so that's the same thing. Okay, so this is the same as e log 2x. Remember one of the powers of logs, you can bring the one of the rules of logs, you can bring the power to the front. So that's ex log 2 dx. Okay. How do you integrate a log? You have to have integrate an e. You must have the derivative in front. So let's differentiate this thing to see what we get. To differentiate a log, an e, the derivative of that is log 2. The derivative of that is log 2. And the function as it is. So before I integrate this back, I must have log 2 in front. So I balance outside by 1 over log 2. So it's 1 over log 2. I can now integrate that. So the derivative disappears and the e function just returns. And we're going between 0 and 1. Sub in your 1. So it's e to the log 2. Take away, sub in your 0, so it's e0. E to the log 2 cancels off to give you 2. E to 0 is 1 to give you 1 over log 2. That question is particularly hard, so if you're finding it hard to follow that, don't worry too much about that one because it's very difficult.